Good afternoon, everyone. How are you all? I hope you have attempted the test today. So we will discuss the test today, the questions. So let's start. Wait for 1 or 2 minutes. After that, we will start. So Veena, have you given the exam? Okay. So how was the test? Which subject is you felt out of three? Bio. Okay. Out of physics and chemistry, is physics doable? So we will start our session. Okay, not bad. Okay. So the first question says there is a 20 gram of ice at minus 10 degrees Celsius. Okay. Okay. So let's draw it using some diagrams here. This is some 20 gram of ice. This is ice. It is mixed with m gram of steam. So let's suppose in a container, they both are mixed and container has, this is steam, which has a mass small n. So now the minimum value of m, so that finally all ice and steam converts into water. So what is the meaning of minimum amount of steam? If I say finally they are asking minimum value of m. Now if steam was more in amount or more in mass, then the temperature of the water will rise, and it will be on the higher side. So for minimum value, what does it mean? If I say for minimum value of m, the final temperature will be 0 degrees Celsius. This is the meaning of minimum value of m. So now two things are happening. First is ice will melt, or you can say ice will come to a melting point. That is, it is at minus 10 degree. So it will reach to a temperature. I will say ice will reach to a temperature 0 degrees Celsius. From where? From minus 10 degrees Celsius. Then it will convert to water, which is also at 0 degrees Celsius. This is the process going to be happen with ice. Now with the steam, if I say steam will convert to water, first of all, its state will change from 100 degrees Celsius steam to 100 degrees Celsius water. First transition is this one. After that, it will again change to water of 0 degrees Celsius. In the complete process, one thing that is guaranteed, which is heat lost will be equals to heat gained. Now, heat is lost by the steam and heat is gained by the ice. You can see that heat is lost by the steam. How much heat is lost by the steam? First of all, it's a transition, state change. So I will say mass m and state change is L. ml is the heat lost in transition from steam to water, plus mass is m, and from 100 degrees Celsius to 0 degrees Celsius, which is ms delta T. Now, what is the amount of temperature change? It is 100 is equals to. Is it clear now? This is heat loss and heat gained by ice. Ice has initial temperature -10, and it will reach to the ice at 0 degrees Celsius. So that is ms delta T is what? 10 degrees Celsius. Plus there will be a state change. State change, after a state change, you will say ml. Now place the values. This is for steam. This is for ice. Now mass of the ice steam is m. Latent heat of vaporization is 540 plus m, and latent or specific heat of water is 1 into 100 is equals to mass of ice is 20 gram. Specific heat of ice is given as 0.5, 10 plus 20 into latent heat of melting is given as 80. Now you need to solve this equation. It will become 540 and 100, 640 m is equals to 100 plus 1600. So m will be 1700 by 640, 0 and 0. If you divide it by 2, you will get 32 in the denominator and you will get 85 in the numerator. So that is 85 by 32. What are the processes? These are the processes happening. Is it clear? Moving further. This is a very fundamental question, very basic question. You can answer it. Energy stored in the capacitor, they are asking half C delta V square. That is half. Capacitance is given as 20. Micro means -6. Delta V is 100 square. What it will become? 10. That is 10 to the power -1 joule, which is option number A. Very good. This is doable question. Which is option number A. Now, next question. This is also a doable question, I think. Capacitance of a system of capacitors between A and B as shown in the figure. Now, you can say that the points about which they are asking place a battery along these two ends. I have placed a battery. Let's suppose this end has a potential V, this end has a potential 0. So the wire is going at point A. So point A will have a potential V. And this wire is connected by this one, this one. So this point is also has a potential V. Similarly, this point B will have a potential 0. And this point will also have a potential 0. Now, across each capacitor, you can see that potential is same V0, V0, V0. So all these three are parallel. From if I say for parallel combination, if you write C equivalent is equals to C1 plus C2 plus C3, because all are in parallel. If they are in parallel, then again you can conclude C plus 2C plus 3C, that is 6C, which is option number B. Very much doable. Next question. A car is moving on a circular path of radius 100 meter. So that's a simple case. A car is moving on a circular path of radius 100 meter, such that its speed is increasing at the rate of 5 meter per second square. That means its tangential acceleration, its linear speed is increasing. That means acceleration is given as 5 meter per second square. At t equals to 0, it starts from rest. For example, let's suppose t equals to 0, its velocity is, it is at rest. The radial acceleration of the car at the instant, this is not what mentioned here. Instant. It makes one complete round trip. So listen to me. After one complete round trip, the radial acceleration is nothing but v square by r. I think you know that this is centripetal acceleration. So it is v square by r. So r is known. This is known. We need to calculate its speed. If in one round trip, if I talk about the distance it will travel, it is going to be 2 pi r. It is going to be 2 pi r in one round trip. So v square is equals to, it is starting from rest, that is 0, plus 2a s. So v square is equals to 2, acceleration is 5 and distance moved by is 2 pi and r is 100 meter. Can you see that? 2 is the, this one, a is the acceleration which is 5 and s is the displacement. Displacement is what in one complete round, 2 pi r. So you can get that now what is acceleration radial? Radial acceleration will be, a radial is v square by r. V square is 20 pi into 100 by radius is again 100. It will be cancelled. That is 20 pi meter per second square, which is option number B. Which is option number B. Is this question clear? So another one, if I talk about is circular curve of a highway, I will give you 20-30 seconds for this to solve. Very easy question, the formula based question. A circular curve of a highway is designed for traffic moving at 72 km per hour. Velocity is given as 72 km per hour. Can you convert it into meter per second? Because all other distances are in meter. So you can convert it, that is 72 into 5 by 18 meter per second. That is 20 meter per second. So velocity is known. If radius of the curved path is 100 meter, the correct angle of banking. So angle of banking, I think you know that tan theta is equals to v square by rg. I think you know the relation. Put the value. Tan theta is equals to v square means 20 into 20 divided by r is what? 100 into g is again 10. 0, 0, 0, 0. That is 2 by 5. So theta is equals to tan inverse 2 by 5, which is option number C. Have you solved this question in the exam? Veena, have you solved this question in the exam? Very good. Now, this one, the spiral spring. Okay, a spiral spring is initially unstretched. Okay, let's draw. Spring is initially unstretched. This is unstretched spring. It is first stretched by a length x. Okay. It is first stretched by a length x. So this length is x. Clear? And again further by a length x. Again it is stretched. So this length is again x. This is the given thing. The work done in the two cases are W1 and W2 respectively. Then the, or you can say ratio or the relation between W1 and W2 is asked. Okay. So work done in stretching a spring is what? Half kx square, you know that. But if you go with the basics, the work done is equals to half k x square. This is good. But when you integrate it, the term actually becomes x initial to x final. This is the actual term that you should know. Are you getting my point? The work done in stretching a spring is what? Half k integration x dx. So that x dx integration, if you say, it will become x square by 2. The complete term is this one, half k x square. But the limit of this x square are initial to final. So if I place the values here for W1, W1 will be half k. You can say that x square is good, but initially it was unstretched. That means 0 to x. So it will become half k x square. Equation number 1. Now, finally, if I calculate W2, W2 is the work done from half k x square. Limit will be what? This is the limit. This is a original 0. It is stretched from x and total is 2x. So the limit is initial position is x, final position is 2x. So if you solve it, that is half k. Put the upper limit, that is 4x square, minus the lower limit, that is x square. So W2 is equals to half k into 3x square. So if I again say half k and x square is nothing but W1. So W2 is equals to 3 times W1. This is option number C. This is option number C. This question is also doable, but the thing you should remember is this one. They can ask you the stretching from any of the points, from x by 2, from x by 3, from 2x, from whatever, but you should remember the relation. Moving further. Okay, this is again a simple question. A solid conductor has a cross-section area 1 centimeter and 2 centimeter square as shown. Clear. A current of 20 ampere enters at A. That means a current of 20 ampere is entering from this side. And we know that charge cannot be accumulated inside the conductor. That means this current will also come out from B. That means current coming out of B is also how much ampere? 20 ampere. Entering is also 20 ampere and coming out is also 20 ampere. That means one question can also be formed as the current at which end is equal or greater. So both the ends current will be same at both the ends. One thing that is clear. Next is they are asking about current density. Current density, if I say it is denoted by J is equals to I over A, where A is the area of cross section, I is the current. Now you can say that current is constant. So J is reciprocal to A. J is reciprocal to A. Very good, Veena. If J is reciprocal to A, that means lesser the area, higher will be the current density. So current density at A is greater than current density at B. This is option number B. This is correct option. All other options are wrong. Okay. Another question. In an electromagnetic wave, the electric field oscillates with amplitude 48 volt per meter. That means electric field, maximum value of electric field is 48 volt per meter. The RMS value of oscillating magnetic field will be, that means they are asking magnetic field, the RMS value of magnetic field they are asking. So first of all, you should know that the ratio of maximum values of fields is C. C is the speed of light. C is the speed of light. This is the golden formula of electromagnetic waves chapter. I hope everyone have studied that formula. So now if I say B naught is equals to E naught by, say, place the value 48, E naught by C is 3 raised into 10 raised power 8. That is 16 into 10 raised to the power minus 8. This is magnetic field. The unit of magnetic field is what? This is what? E is pronounced as Tesla. Now magnetic field is known. They are asking the RMS value. So B RMS is equals to B naught by root 2. That is 16 into 10 raised to the power minus 8 divided by root 2. You can solve it. And if I rationalize it, it will become root 2, or it will become 8 root 2 into 10 to the power minus 8. That is 8 into root 2 is 1.4. 1 into 10 to the power minus 8. Multiply it. 8. 11.28. Approximately 11.28. That means 11.3 into 10 raised to power minus 8 Tesla, which is option number D. Try solving another question. This is the question based on equilibrium. I hope everyone of you knows the equilibrium thing. How to solve the questions of equilibrium. Equilibrium means if I say one or two things to you, listen. We will solve the question in the left part. Now, if I am saying, let's suppose two charges are placed at some separation. Q1 and Q2 are placed some separation, and they are saying the both are of same natured charge. The nature is same nature. Either they are both positive or they are both negative. So these are the same natured charge. Now the question is, if I want to place a charge, place a third charge, whether it is positive or negative, doesn't matter. I want to place a third charge on this line AB. On this line AB, such that that charge remains in equilibrium. Such that that charge remains in equilibrium, then the third charge should be placed inside the line or between the points A and B. This equilibrium point. This is the equilibrium point. Remember my thing, the words I am saying, if two like charges are there, like charge means same nature charges are there, then the third charge which will be in equilibrium will lie between A and B anywhere. And near the smaller charge. Between A and B, it's true, and near the smaller charge. Write down these points, actually, it will be very useful. Now, the second situation comes when two charges are of opposite nature. Q1 and Q2 are of opposite nature. In that situation, if you want to place a third charge such that it remains in equilibrium, then that third charge will be outside the line AB. So this is going to be the third charge, which should be outside the line AB. One thing is clear. Now this charge should be nearer to the smaller charge. Nearer to the smaller charge. Keeping these things in mind, it will be very easy for you to solve. Now, in our question, if I come to our question, if a charge Q is placed at the center of the line joining two equal charges capital Q, there are two equal charges capital Q, and a third charge which is small q is placed at the center. So if this distance is r, this is also r, such that the system is in equilibrium. Let's suppose this is point A, this is point B, and this is point C. If the complete system is in equilibrium, what does it mean? It means that net force at A is equals to 0. Net force at C will also be 0. And net force at B will also be 0. That means net force, there is no net force acting on any of the parts. This is the meaning of equilibrium. So if I say for equilibrium of A, for equilibrium of A, if I calculate both the forces, two charges are there to apply force. One is small q and one is capital Q. Both of these are applying force. So these forces must be opposite in nature and equal to each other. So I will equate them. That means force at A due to C should be equals to force at A due to B. And if you calculate these forces, you know that relation Ke, product of charges Q into Q divided by separation is R square is equals to Ke Q square by 4R square. Why 4R square? The separation between A and B is 2R. Now things can be cancelled. Capital Q with the square, Ke with the Ke. So Q will become Q by 4. This is just the magnitude of charge. Now we need to decide the sign of the charge as well, which is very easy to understand. Listen. All these three charges are in equilibrium. Now listen to me very carefully, the thing that I have told you. All these three charges are in equilibrium. For example, if I say this is our system, B and C is our system. These two charges are in equilibrium. The third charge A is also in equilibrium. But the third charge is outside the line. That means these two charges, Q and Q, should be opposite nature. Should be of opposite nature. Why? Because third charge will be in equilibrium outside if these two charges are of opposite nature. That means capital Q is positive, so small q will be negative. So we get small q as minus q by 4, which is option number D. And this question is also, I think, very popular. The result is also very popular. Everybody knows the result as well. Now, if you want to ask anything, otherwise I will move further. Now, a charge of magnitude 3e and mass 2m is moving in an electric field capital E. The acceleration of the charge particle. This is again a very fundamental question. Acceleration is what? From Newton's law, F upon m. B. F is equals to what? Q into E by M. Now place the value. Charge is given as 3 E and mass is given as 2m. 3 by 2m, which is very good, Bina, which is option number B. Have you attempted this question? Question says magnetic flux through a coil is changed. Okay. The variation of induced current in the coil with the time is as shown in the graph. That means current is shown on this axis. There is a current. Current and time graph is given. Okay. First of all, the EMF induced is d phi over dt. We know that. I am not using the negative sign because it's just for the direction. So direction is not required here. E is equals to d phi over dt. And current is equals to E over R. Clear? So if I place the value of that is d phi over dt and 1 by R. So this is the value of current. Or you can say, I'm just modifying the things. I am sending dt here. Why I am sending dt? Because I and t graph is given. So I am sending dt here. I dt is equals to d phi over R. Is it clear? So if I integrate these terms, this I dt integration is nothing but area. What I have written here. This is area of I versus T graph. And if I say R is the resistance and d phi, if you integrate, it will become change in flux, that is delta phi. So the final result that I will get, area of IT graph is equals to change in flux over R. And they are also asking the total change in flux. Total change in flux. So that's very simple. Change in flux will be R times of area. Area of the IT graph, can you calculate? Area of the IT graph, can you calculate? This is a triangle. And if it is a triangle, area of triangle is half into base is 0.1, height is 4. If you put the values, R is given as 10 ohm into this is 0.2, that is 2. So change in, what is the unit of flux? Anyone? What is the unit of flux? What is the unit of flux? Weber. Very good. So you can write it as 2 Weber. Moving further. There is a toy train which consists of 3 identical compartments X, Y, and Z. It is pulled by a constant force. Okay, first of all, draw the situation. This is the horizontal surface. There is a toy train which has 3 identical compartments like this. It is placed horizontal, however, it doesn't look like it. It's looking like the inclined plane, but you can understand. It is pulled by a force F. It is pulled by a force F. Okay. Assuming there is negligible friction, the ratio of tension in the string. So three compartments X, Y, and Z. The tension, if I say these are the three identical bodies or identical compartment, let's suppose mass of each is small m. One thing is clear. Now the tension, there are two strings, so there will be two tensions, and tension is always away from the contact point. So this is, let's suppose T1 and T1. Similarly, this will be T2, T2. This is the tension. Okay. Next thing is, try to understand the process. These three masses are connected and they will move together with the force by this force F. If they are moving together, then acceleration of the system, you know that acceleration is equals to force divided by total mass, and total mass is nothing but 3m. So this is the acceleration of total system. That means each compartment is moving with this acceleration. Now, if I talk about for compartment X, only T2 is acting on this X compartment. Only T2 is acting in this horizontal direction. You can see that. So net force T2 is equals to, should be equals to mass into acceleration. Mass into acceleration. Are you getting my point? How to write these equations? T2 is equals to mass into acceleration. So T2 will be, mass is m, acceleration is F by 3m, because each of the block is moving with same acceleration. That is cancelled. So T2 is equals to F by 3. Very good. This is for compartment X. Now, if I say for compartment Y, how many forces are acting on Y? You can say T1 is in the positive X direction, T2 is in the negative X direction. So you can write T1 minus T2. These are the net forces, is equals to mass is m, acceleration is F by 3m. This m and this m will be cancelled. So T1 will be F by 3 plus T2. T2 is again F by 3, so T1 is equals to 2F by 3. Now tell me, according to the question, which ratio is asked? Whether they are asking T1 is to T2 or T2 is to T1. Which ratio they are asking? Tell me. According to the question, which ratio they are asking? T2 to T1 or T1 is to T2? Connecting XY and YZ. So connecting XY is T2 and connecting YZ is T1. So T2 over T1 they are asking. T2 over T1, very good. So if you calculate T2 over T1, that is F by 3 divided by 2F by 3. What you will get? 3 and 3, F and F, that is 1 is to 2. Which is our option number? Which is our option number? C. Option number C is correct. Clear? Moving further. I think this is the question that we have already discussed in one of the test discussions. I hope so. I don't know whether you remember or not. If you remember, then you can say yes. Otherwise, it's always a no. I will draw the diagram actually. These are the two mirrors, M1 and M2. These are the two mirrors. And a ray is incident on this one, like this. This is the normal. So this ray will go, you can see that angle given here, this one is 30. So by the law of reflection, this one will also be 30. Clear? If this is 30 by calculation, by geometry, this one will be 60. Clear? This is given as theta, which is the angle they are asking. Now they are saying after the reflection, light reflected from M2 is parallel to M1. Now this is M1, this is M2. They are saying that after reflecting, the light becomes parallel to the first mirror. This is the light. Now, what does it mean if I draw the normal here? This will be the normal. Is it clear? This will be the normal. Now it's completely a pure geometry, nothing else. This angle is given as theta. The M1 and reflected rays are parallel, so you can say that this angle is also theta. Clear? I'm doing nothing. This red line is the normal, out of which some angle is theta, so remaining angle is 90 minus theta. Similarly, using laws of reflection, this is also 90 minus theta, so this will be what? Theta. This will be what? Theta. So in the triangle, if you can say, there are two angles, theta, theta, and 60. Theta, theta, and 60. Total is 180 degrees. So you can say 2 theta plus 60 is equals to 180. So theta is equals to 60 degrees. There is nothing physics in it. No physics in the question. There is only, this is complete geometry. This is complete geometry. Clear? So theta is 60 degree, which is option number A. Moving further. This is easy question. Have you attempted this? Anyone? A particle is moving along a straight line whose position is given as x is equals to t cube minus t square. Now, average acceleration they are asking. Average acceleration is what? First of all, you should know average acceleration is what? Change in velocity over time period. Change in velocity over time period. So we need to calculate the change in velocity. Time period is given from 2 seconds to 4 seconds. So this is the time period of 2 seconds. So for the calculation of change in velocity, if I differentiate it, it will become velocity is equals to, if you differentiate, it will become 3t square minus 2t. Is it clear? Velocity is what? Dx over dt. Dx over dt is what? Velocity, and velocity, if you differentiate, it will become 3t square minus 2t. Now this is the velocity. At t equals to 2 seconds, we will get initial velocity. We will get, because they are asking from 2 to 4, so v initial is at t equals to 2 seconds. If you put t equals to 2 seconds in it, it will become 3 into 4 minus 2 into 2. How much it will be? 8 meter per second. Am I right? Now at t equals to 4 second, if I write, so velocity will be final velocity. And if you put 4, that is 3 into, if you put here 4 square, that is 16 minus 2 into 4. That is 48 minus 8. Is it 40? Now you know the final velocity. Now you know the initial velocity. Now you can put it here. So it will be become V final minus V initial over T. Put the values 40 minus 8, that is 32 by 2, 16 meter per second square. 16 meter per second square. Now, can you tell me the instantaneous acceleration at t equals to 4 seconds? Can anyone tell me the acceleration? This is the question that is done. Now, tell me the acceleration at t equals to 4 seconds. Can anyone tell me? Acceleration at t equals to 4 seconds. Say yes or no. Or you are solving the question and will answer. What t? Priyadarshini? No, it's not going to be 40. Veena, it's not going to be 40. Acceleration at t equals to 4 seconds, if they are asking, that means they are asking for instantaneous acceleration. And instantaneous acceleration is what? dv over dt. Instantaneous acceleration is what? dv over dt. Now you know the velocity. You know the velocity is this one. If you differentiate this term, you will get 6t minus 2. Now put t equals to 4 and you will get acceleration at t equals to 4. That is 24 minus 2, which is 22 meter per second square. Is it clear? Now, tell me one more thing in this question. I am taking too much time in such question because these are very important question of kinematics. And you had a class on kinematics recently. The question may be something that acceleration is given as 2t plus 5. Then find velocity. Find velocity at t equals to 2 seconds. Acceleration is given and the motion is started from rest. Find velocity at t equals to 2 seconds. What will you do in this case? Do you know the procedure? Just write, just don't solve it. Just write down what's going to happen in this question. Or you can remember one thing. There are three things. One is position, one is velocity, and one is acceleration. If you are if you are moving from left to right like this way, you need to differentiate. And if you are moving right to left, then you need to integrate. Okay, Veena has solved the question. It is 4. Okay, have you integrated the relation? Have you integrated it? Okay. Okay, so I'm not going to check the answer. But if you have done the integration, then it's good. If acceleration is giving and they are asking the velocity, then you need to integrate it. You need integration. And if velocity is given and they are asking acceleration, then you need to differentiate it. So that's simple thing. Moving further. When a metallic surface is illuminated with monochromatic light of wavelength lambda, the stopping potential is 5 V naught. So first of all, you should know the relation for stopping potential. Do you know the relation for stopping potential? Do you know the relation of stopping potential? I think everybody knows. If you don't know, I will make you learn the relation of stopping potential. One thing that everybody knows is K max is equals to E minus psi. This is the relation everybody knows. E is what? Hc by lambda, energy of photon, minus psi. Clear? K max is what? Maximum kinetic energy. And maximum kinetic energy is nothing but EV naught. This is again a golden relation that you should remember. So what it should be, V naught is equals to Hc by lambda E minus psi by E. This is the relation for stopping potential. Now the question says, if the light incident is of wavelength lambda, then stopping potential is 5 V naught. So first situation, I am putting the value 5 V naught Hc by lambda E minus psi by E. Psi is the work function. This is equation number 2. Now in third situation or second situation, they are saying if the light is wavelength 3 lambda, then stopping potential is V naught. That means V naught is equals to Hc, wavelength is 3 lambda, E is already there, minus psi by E. They are asking the work function. So you have two equations, second and third. If we solve these equations, these two equations, so is it possible that we can multiply 5 in this? And if we subtract these, then this V naught and V naught will be cancelled. Clear? So what will be remaining thing? 0. LHS will become 0 is equals to Hc by lambda E minus 5 Hc by 3 lambda E. This is the one term. Clear? Plus ka, this is 5 psi by E minus psi by E, that is 4 psi by E. Now you can see that Hc by lambda E is common. 1 minus 5 by 3 plus 4 psi by E is equals to 0. That is 3 minus 5, that is minus 2 by 3, or you can say minus 2 by 3 Hc by lambda E. If I bring this term to the left side, it will become positive, is equals to 4 psi by E. E and E will be cancelled. 2 and it will be 2. So psi is equals to Hc by 6 lambda. Hc by 6 lambda. Hc by 6 lambda, which is option number? Is there any option Hc by 6 lambda? Option number A. Is it clear? One more question we can take here. The question says, a small mass executes linear SHM about O. So it's executing linear SHM about a point O. Okay. With amplitude A and time period T. Okay, these things are given. Now, amplitude A means the distance from O. Let's suppose this is maximum point A and this is another extreme point B. So amplitude is given as A. Its displacement from O at time t by 8 after passing through O. So listen to me very carefully now. Particle has just passed from O. Let's suppose at t equals to 0, it has passed from O. So after time t by 8, it will be somewhere here. It will be somewhere here. So the distance from O is asked. One thing to be sure, the general form of SHM is x equals to A sine omega t plus delta. This delta is phase constant, omega t plus delta is complete phase, A is the amplitude. This is the general form of the equation. Now, if I say, if particle is starting from the mean position, remember this thing, if particle is starting from mean position, if particle starts from mean position, then its equation can be written as x is equals to simply A sine omega t. In that situation, delta will be 0. And if the same particle starts from the extreme position, that means from the amplitude position, its equation may be written as x equals to A cos omega t. A cos omega t. Remember these things. Now I know the equation. Displacement is asked. Amplitude is given as A. Sine omega is what? 2 pi over capital T. This is omega. Into time is given as t by 8. T and t will be cancelled. So x will be A sine pi by 4. 2 and 8 will be cancelled. Sine pi by 4 is what? Sine 45. Sine 45 is what? 1 by root 2. So it will become x is equals to A by root 2, which is option number D. Which is option number D. Done. Okay. So right now we are ending the class. Bye everyone.